Excellent.
All right. So welcome everyone to this month's Monitoring Power Hour, and thank you everyone for joining. Today we're going to be talking about using geotechnical sensor data for real-time monitoring in T4d. And so throughout the presentation, if you have any technical difficulties, maybe you can't hear us or you can't see the screen, just type in the chat window and let us know so we can handle it. Also, if you have any questions throughout the presentation, you can add them into the chat window and we'll answer questions as we go, and we'll save some time towards the end of the presentation as well. All right, let's move to the next slide. So just to introduce presenters today, so myself, Riley Smith, I work at Trimble Geospatial. I'm market manager for monitoring and tunneling, and I'll let Ramiz introduce himself.
So Ramiz Imanovic, as you can see, I'm working for Trimble for several years as a geodesist, and in the last years in the role of a senior quality engineer, doing actually mostly time on monitoring, but some other Trimble products actually we have in-house.
Awesome. All right, so today what we're going to go through, we'll first talk about what are geotechnical sensors, where are they used, and the context for them in monitoring. And then we'll also get into a demo, the really exciting part, and talk about how do you use those geotechnical sensors in T4d. And then towards the end, we'll talk about resources, what you can do if you would like to find out more about T40, Trimble monitoring, and so forth, and some look at some of the new things that we've been doing from Trimble monitoring team, and we'll save some time for questions and answers as well. So first I wanted to talk about what geotechnical sensors are. So it's somewhat of a wordy definition, but I think it really defines what a geotechnical sensor is because they are quite a broad category. So the purpose of geotechnical sensors is to monitor the response of the natural, so being the land, what exists on the earth naturally, and the built environment. So this would be something constructed by humans, whether it's a building, a tunnel, railway, and how that responds to external factors. So that factor can be anything. It can be weather, it can be movement, it can be somebody pushing on something, it can be a variety of things. And that is done through using sensors, which are devices that respond to some sort of physical stimulus, and that can be movement, it can be temperature, pressure change, and that transmits a response. And that response can be electrical, which is more often than not, but it can also be a physical response. It can be a change in, let's say, string tension or maybe a tape measurement, so a variety of different ways. And that response is translated into some kind of data that we can use to assess the monitoring. And that can be ground dynamics, so let's say movement in 1, 2, or 3-dimensional space. It can be kinematics, so you can be looking at forces, tension, stress on an object. It can also be environmental variables. It could be the change in temperature, pressure, water levels, and a variety of other things. So quite a broad category of sensors as well as the type of data that can come from them. And really they're used in all sorts of industries. I've named some here, but this is definitely not the comprehensive list of where geotechnical sensors can be used to monitor things. So dams, mining, construction, structures, and a variety of others. So we'll look at a couple examples of where you would see geotechnical sensors installed on some primary large construction and other projects. So in this case, we have a metro tunnel where you can see that we have not only geotechnical sensors on and in the tunnel itself, but also on the structures above and the surrounding ground surface around the tunnel. So things like rod extensometers used to measure changes in length and position, as well as tilt and crack meters assessing how that crack is expanding or contracting, and load cells for understanding different loads and forces that are on the tunnel surface and so forth. So you'd see them in a lot of areas around the tunnel. Now in excavation, so let's say creating a big pit for building a structure, the foundation of a structure. So you have the shoring and different things around the excavation where you're installing various sensors to understand how the load from the surrounding ground and movement maybe of traffic surrounding it is affecting that structure, whether that's the load cells measuring the force and the strain, but inclinometers also measuring changes in the structure, whether that's an angle or position, and a variety of other things like strain gauges also checking the stresses on those structures. So a lot of this, as we're going through, you'll notice is more relative. In survey and mapping applications, we a lot of the time work in absolute, but with geotechnical sensors, we're typically looking at relative measurements. How are certain things moving relative? So then the last application that we have here is a dam. So a lot of time we'll have geotechnical sensors embedded in the dam structure, the surrounding area, to understand how it's moving relative to the forces of the water, changing water levels, and environmental factors. So getting more into what some specific geotechnical sensors are, and these are some common examples, definitely not all of the examples that are available, but some common ones that you typically see on these types of monitoring projects, like a pressure sensor. So this can be used to correct the measurements from a total station, so the ppm measurements, but can be also used for other things, whether it's correlating to certain movements that are happening. Piezometers as well for measuring the water table. This is especially useful in the case of dams. Extensometers, these are used in a lot of areas. One that we see a lot is in slope stability and understanding how that slope is moving over time and reacting when it moves too much. Tilt meters, so this is used commonly in structures, assessing whether temperature changes are affecting that structure. So is it heaving or settling, and evaluating those movements over time relative to other factors. Crack meters, as it sounds, typically monitor the displacement between 2 points where a crack or a structure is moving back and forth. And as well, temperature sensor, which can be used to correlate both the movement to maybe fluctuations in temperature, but also to help correlate with other types of movements. So now looking at the workflow, so before we get into the demo, we want to cover how, from a high level, how does this workflow look on a monitoring project? So first you have the geotechnical sensors. So there, as we mentioned, they're monitoring some kind of physical stimulus, and they're transferring that in a digital way or electrical way to a data logger, which converts that data into engineering values or really results that we're looking for, whether that's movement or changes in position. And then that data can be brought into T4d server, where we can read that data in. So this is more of a, as it says at the top, a file-based workflow. So we can read in CSV files where we take the data from the data logger, whether that's a one-dimensional, two-dimensional position, and store and configure all of that data, and then move into T40 web, where that's the visualization, analysis, and alarming piece. So what do we do with that data? We create reports and understand how is it moving over time and assessing those trends. And one key note here that you can see on the top right is the support for a variety of sensor types and manufacturers, as long as that data can be extracted from the data logger in a meaningful way, it can be supported in T4d. And then the second type of geotechnical sensor workflow using T4d is through what we call the gateway method. So this is where we typically have a variety of sensors on site that are all communicating data to a central gateway, and then that is streaming data to T4d web. So we're actually kind of limiting and removing a few key elements that you saw in the file-based workflow, such as the T4d server, because all of the data is being streamed in real time to the T4d web, so we can visualize those results in real time throughout that project lifecycle. So this is kind of the new way of geotechnical monitoring that you see being used more often on projects. So with that, I think I've talked long enough, and now let's jump into the demo. So I'll switch my screen here. Now, Ramis, you should be able to go to the sharing and share your screen.
Now you have to change presenter, right?
Yeah, here you go. I'll just take a look to see if there's any questions so far.
Right. Which screen?
So I'm seeing your web browser screen where it says connected to GoWebinar. GoToWebinar.
Okay. Do you see now the second one, right?
I don't see a screen yet. Oh, there we go. Yep. Yeah, I see T40.
Right. Okay. Thank you. Relay, you got actually now the very rough overview about the abilities we have in T4d, and I would like now actually to jump into the implementation, or what we implemented in T4d software, and to show you actually these geotech support from beginning, from the importing and data acquisition to the visualization and alarming. So let's start here. To speed up, actually, I just prepared something. Otherwise, it would take much longer. But to keep it simple, I will just explain what we have here, what you see here. You see here 3 data loggers, which is actually module in our side to grab data from any data logger, which is outputting measurements in an ASCII file. Just a simple CSV file in a certain format, which can vary it a little bit. We are not sticking to one format. There is some variation we are accepting, and what you are able to grab all these data out of the file. And normally in a monitoring, the file is created all the time or regularly from the data logger, and we are regularly grabbing that and reading. So let's demonstrate only simple one or these 2 data loggers, just to show you actually what happened. When you add module to the T4d server, you will be navigated by a wizard, like something like that. Add data logger, and in the wizard here, you can take create a name, and then after that, you are specifying actually which data logger, serial number, and so on, and the file format, which file you would like to take, and so on, which is a text file, a CSV file must be, and so on. When you're so far, when you finished with that, everything what happened, actually the module starts to read the data out of the file. And here in this example, you see already what happened. I have one sensor which I called wind speed direction, and inside of this sensor we have 2 components. We have direction and wind speed in certain engineering units, which is also important to say. We are expecting out of these CSV file actually engineering units or SI units. As you see, the velocity, SI units for velocity is meter per seconds. Other case, rainfall from rain gauge. I am getting here currently no rain. we have really dry air here. So, and as I said, this is just a simulator for you. You see here from name, this is a from my side actually named a manufacturer, just to present you the data, which means doesn't matter who creates the data. For now, from the point when a file is there in the certain format with the specific measurements, actually the work for T4d is starting. Okay, we have now few sensors from these data logger, much more, and you see here with some sensors we are delivering also temperature, and temperature is some kind of essential value which you should look on when you are reading measurements out of a device, because if the temperature is growing and you don't know why is heated up, because it's really hot outside and the working temperature is mostly specified on all the devices, then this is the first judge actually, can you rely on these measurements or not? Is device still in the working temperature scope, or yeah, in the working temperature values. So on the that would be a server part, which is actually why we did that. The reason is actually we just prepared the data transition to the web part, which is responsible for visualization, alarming, reporting, charting, and so on. So going to the web part, what we have there is actually I would say we can jump, yeah, we can jump actually here to the projects. And in T4d, the first page would be you are landing here and you are creating a new project, saying, okay, create something and work on that. I would also avoid to do that now, just because of time. And this is nothing special. This is name, description, and unit preferences. Okay, I have already created one. This is this project, and what we have here, this is my active project. What we have here, we have sensors. We created a lot of sensors. How you do that? You are adding a sensor here, a single sensor or multiple sensor at once, or some geotechnical sensor types explicitly. One way, and the other way is using gateways, which is actually a new, more faster, more automated way how we can gain data from some geotechnical sensors. And this is important to mention. Currently, we are supporting two big providers like Load Sensing and Sensive. All the sensor they are putting outside, they provide gateways from their sensors, and we are able to grab the data from the gateways. I will come to that a little bit later. Okay, let's jump to the sensors which oh no, sorry. Let me go back a page. I would just stick to the to one of the sensor, let's say like wind speed and wind direction, which is mostly delivered by some weather station. So let's demonstrate that. Let's show in a project how to add these sensor. Let's say wind speed. And as I said, normally as from the sensor type is some kind of a weather station. And the weather station can provide several components, but we are looking these two. And what we see here, this is the source on the server side, which we prepared, and I'm selecting that, and everything is already pre-selected actually from which data logger and which data types. About data types, that was a big discussion actually to which level to granulate that, but actually we decided, okay, to the level where the simple interpretation of the numbers can be defined, like does this number interpret a temperature, or in this case wind speed or wind direction. It is not enough to say is that a scalar value or double value or string, like developers knows. That would be much simpler, but the end user could not deal with that actually. So we had some kind of granulation, and you will see later the list of granulation of the types. Good. Let's continue. On the next level, we have to provide location. You see here, I have already some kind of values, and this value is actually for the first easting northing value for Colorado Central Coordinate System. And my simulator doesn't provide the location, which means I have to enter here some location or use already some existing location, which can help you actually to locate that in a map. So I would say I would use this value and place it somewhere, and let's say my speed and wind, something like that. Each location can have a name. Please do not mix that with some geodetic points. These locations are only to show the sensor in the map view. And last page is summary, and everything is collected there. When we save that, we see everything is connected, everything green, fine, and we see our sensor is wind speed. That's what we created now. Okay, and you see here the data types as wind speed and wind direction. Okay, and on the similar way, you would create all other sensors here, like moisture content, like things like that. And I already did a few of them, and here in the sensors list, actually we can see them. Normally, you have a lot of sensors, and how to navigate that, it's the easiest way actually to say, okay, I would like, I don't know, select only temperature sensors. And this is my sensor, providing me a really real data. This is the source, and these sensors in web contains all this needed information: location, name, and what is the last value. And charting, you would see actually what is the last few days of the data, and how the temperature is actually changing. And we see here that yeah, from yesterday to tomorrow, temperature went down, right, Relay? In Colorado.
Yep.
This is a temperature sensor from Colorado.
Yeah, thankfully, it was really hot.
Yeah. And in these few hours here, I think that was some construction work near the unit, and temperature just fluctuated a bit more. But okay. On the other side, I would like to my solar radiation, for example. This is simulated data. You see here from the chart.
Yeah,
There's
just to
no
let you know, there's a slight delay in the screen share from when you're seeing it. So
okay.
about 2 or 3 seconds.
Oh, that's a little bit much, but okay. Let me just switch the screens a little bit more slowly. Good. That was actually the way of bringing the data out of the CSV file into monitoring, bringing or creating into a sensor object, which is in monitoring web actually an object which can be visualized, which can be put into an alarm engine, can be reported, and everything around that. That's important because the whole concept of web is created on the particular sensor and has location and can be shown in a map. I would say via here, as you see, I just put some values around the Colorado Westminster office. Actually, we have here. Okay, there is no meaningful location actually, but yes, that's the way how you would see the sensors in the map. Okay, I would like now to jump to the gateway, and here I already connected to 3 gateways we have, and created this gate actually to grabbing data and showing actually what we have already there. And for example, from a Sensive gateway and the project and accounts we have there, their data we are actually acquiring now. What is listed here are actually all possible sensor we could get. For example, this one is not yet in the system. We could grab that too and say, okay, import that, and we would get all these tilt ABC and beam displacement. Okay.
So this is the gateway workflow is a lot simpler because the sensors are already configured, so all the data is essentially can get into T40 web without very little configuration.
Definitely, that's actually the sentence I wanted just to say. Yes, with this one click, actually you have already there. Everything is there, is automatically created. That was active work with Sensive and load sensing to provide this information. So, and with this step, actually, you have everything here, and looking now to the sensors. Let's say I would sorry, optical displacement. I wanted actually this one to see how it looks like actually what the sensor is providing. Here we have all the information, the last reading, and the most interesting part is actually the chart, and here we see actually the values. There are real values here, so far I know, and they are temperature values, and I guess some correlation with the temperature could be seen here. Some correlation. So far, temperature is down, the value are up. Here, yeah, at least the very clear and visible correlation is actually here in these level. Yeah, and things like that. That's actually the advantage of one additional tool we have in T4d, which is called Analysis View, that we can combine such information in one chart. Here, in this case, one sensor provided all this information, which are combined, but let's say how to combine these values with some prism movements. Our total station detects some prism movements, and how would you actually combine these information with meteorological measurements and I don't know, moisture content, things like that, to be able to judge the movements and to take a proper reaction on that. To demonstrate, or just to show a simple one, I already created an analysis view, and this view here is containing a temperature reading from a roof, and here terrestrial position, delta values, you see delta heights, of a target which is measured near this sensor here. So, and here actually you can clearly see that there's really some correlation between temperature and the high movement, or the movement in the height of the position.
So in this case, it's a geodetic, so a total station observation, and
right.
a geotechnical or a temperature sensor. So you're kind of combining the two in a way.
Right, you can combine with some moisture content, or I don't know, some tilt sensor, just to make sure, okay, you have values from totally a different sensor which are matching with the movements, which means that they correlate in the time. There's correlation in the time, and you can be sure, yes, everything is actually everything is fine. But you can make sure this is right what you see, and then you're looking for other source. Why is that happened? Why something moved or tilted should not happen, and so on. Then you're going to a construction site or analyzing the ground, things like that. But I was not able here to simulate moisture content on the way at the way that so much pretty. So I'm not able to simulate the nature. Sorry about that. Good. I think so far I am done what I wanted to present.
Yes, maybe we could, there is a question maybe that you can answer that was asked about, does T40 support the use of Campbell scientific data logger?
Yes, that's actually the first data logger we supported. We created a module for that, and the module is actually grabbing a CSV file out of that.
Okay.
That's on the same way. Data logger, Campbell Scientific Data Logger is able to output a CSV file, and we're reading that, and that's it. And this is a very nice data logger. Can grab anything. Actually, you have 10, 20 sensors on that, and yeah, that's supported.
Good. Doesn't look like there's any other questions right now. So if anyone on the webinar has any questions, feel free to enter them in and we can get to them. One question I have that I think you've already covered, but it's good to reiterate. So the focus of this webinar was geotechnical sensors, but also to tie everything together. So if I had a project where I had multiple geotechnical sensors, but also geodetic like GNSS, total station, and maybe level observations, I can combine all of that in one T40 project and then create these like views like you're showing, where I have multiple sets of data in one view, whether it's GNSS or a temperature sensor, whatever it might be. Is that correct?
Right.
Yeah. Oh, there is a question that came in. How many, so this is regarding the setup M1. So this is the setup M1 for everyone to know is for more the total station based workflow, but regardless, we can answer this question. So how many sensors can you connect to the setup M1 for real-time connectivity?
Good question. I would actually speak up that with a setup M1 guy, because to be honest, I cannot give a right answer or correct answer right now. Actually,
Yeah. Typically
there's more. They're supporting multiple, but I don't know exactly what. You can,
how many?
for example, just to jump related to setup M1, you see this temperature sensor. This is actually connected via ISD Connect gateway from setup M1. This is a temperature delivering from the sensor, which is connected or hanging actually on setup M1 unit in Westminster, Colorado, on the roof. Yeah.
Oh, very cool. Awesome. All right. Well, it doesn't look like there's any other questions, so I'll take back the presenting rights, I think, here. And we can finish up the presentation with some next steps and some more information. All right, you can see my screen okay?
Yes.
All right. So thank you for that demo. So just to summarize what we've talked about so far in the presentation. So we talked about geotechnical sensors, what are they, and where are they typically used, what kind of projects, and then how those are supported in Trimble 4D Control, as well as on T40 Web, and how we can use that, configure those both from a file-based workflow, which is what we were mentioning before with the Campbell Scientific Data Logger, where we're taking in files from that data logger and reporting on that data, and also the workflow of using a gateway sensor, which was the case of showing, I believe you showed a Sensieve or a load sensing example of using that data. And then also showing some typical examples of reports and charts where we have one sensor, but also can have multiple sensors in one chart to show correlation of that data. So with that, I want to announce to everyone that version 6 of T40 is now available as of yesterday. And so a little information on this release, we're announcing a new 3-tier addition structure to T4D, what we call field, intermediate, and advanced. And the idea behind this is to structure T4D in a way that it can be deployed based on a project type and duration, as opposed to one standard format. So now, depending on what the project may need, maybe it's only optical, maybe it's GNSS and optical, maybe it's, like we showed today, geotechnical as well as geodetic sensors. So that's what these modules are bringing that capability to use. As well, also a 3 and 12-month subscription term. So instead of just the perpetual license offering a T4D, there's now also the option to buy T40 in 3 and 12-month terms. There's also a lot of features and improvements in the geotechnical workflows, especially what we were showing today, that you can find more information about in the release notes or on the new Trimble monitoring website, which I'll show a link to that here in a second. If you're using T40 currently with an older version, you can upgrade if you're under current maintenance and support to T40 advanced version. So more information on that. If you're curious, I suggest that you reach out to your local Trimble distributor and they can help you go forward with that if you're interested. And there's also a promotion available. There was a question that was asked about this, so I think it's a good item to note. There is a promotion that will be available if you're not under current warranty and you want to reinstate or extend or get back into T40. So definitely contact your local distributor and they can get you some information on that. Oops. And some resources. So if you're curious to find out more about monitoring in general and Trimble monitoring, we've got a new fancy website called there at monitoring.trimble.com, and I suggest everyone, if you have a chance, to go there and check it out. We also have a YouTube channel which has is a great resource for training and tutorial videos on a variety of different things in T4d, whether it's setup, configuration to reporting and charting. And we've also been holding these monitoring power hours monthly. So if you want to view any of the previous recordings, you can go to the Trimble Geospatial webinar page, and they're all hosted there. As well, we'll be continuing to have them. So look forward to next month's for the power hour. As well, contact your local partner. I mentioned this before, but if you're just looking to have some questions answered that you may think of after this webinar, or you want some more information on T40, feel free to reach out to them. And with that, so today we covered about using T40 and geotechnical sensors. The next webinar that we'll be covering in August will be focusing on everything T40 web and how you can set up different charts, analysis, and a variety of other features in T4D web. So keep an eye out for that, for the webinar registration link, and I hope to see you all there. And so, oops, I had some animations. And with that, we'll take any of the questions that have been answered, or if anyone wants to type any now. Looks like we've got one question that came in. So question here, Ramis, maybe you can help me answer this. So if I want to use GNSS with T4D web, what version of T4D do I need to do that? Well, I would suggest the brand new version, but
yeah. Actually, does the combination of two survey methods, you can either have intermediate or advanced. Intermediate would mean actually you can get all the time series in the monitoring project, but on top on that, you are doing your visualization, you alarming your report, which means this is created mostly if somebody don't want to use T4D alarming, visualization, charting. You have perhaps some customized application which is looking for the source, for the time series. And we are able to create these time series, which means combining terrestrial and geodetic measurements. Mostly outcome out of that is some adjusted coordinates, some position and reliable position, I would say, and not all of the customer or user outside can create that. Actually, that's the feature or the ability of us mostly. But creating any chart, perhaps somebody can do else. And if somebody has such application already in house, okay, they can save a few bucks here and say, okay, we don't want to have the T4D visualization, alarming, reporting capability. We have our own. But combining terrestrial and GNSS from the intermediate version.
Cool.
And advanced version.
Yeah, and the advanced version has all of the T40 web capabilities in it as well. Yeah, awesome. Thank you for the question. So we'll just give maybe another minute to see if any more questions come in. There was a question about getting a demo of T4d. So what I suggest, if you're interested to get a more in-depth or personal demo, is reach out to your local distributor, Trimble distributor, and they'll be more than happy to give you a kind of a more in-depth view of T40 and the features available. If not, the other option is to look at some of the videos that we have on YouTube, and as well some of the power hours that we've done over the past 4 months. All right, it doesn't look like there's any more questions going in. So thank you everyone for your time and attending this webinar. I hope it was informative. And thank you, Ramis, for the demo, the great demo of all of the geotechnical workflows. And there will be a follow-up after you leave the webinar. There will be a follow-up feedback form. So if you do have any questions that you think of, feel free to enter them in that form, and I'll reach out to you all after the webinar and connect. All right, well, thank you for that, and see everybody next month for the next monitoring power hour. All right.
Okay, thank you, bye-bye.
All right, cheers, bye.